is Holly Smorzewski.
I'm Peter Mills.
I'm Morgan Painter.
I'm Marcus Croker.
And I'm Kelly Barrera.
And today we're going to examine gun-related crimes in Chicago and a ruling in 2010 that ruled that the banning of the ownership of handguns is unconstitutional. So, here's our agenda, and first we're going to start off by going over the question at hand and the problem that we are trying to solve. Then we're going to talk about the measures that we use and how we're trying to answer them. Then we are going to give an analysis over the data that we gathered and what it means for our analysis. And then we're going to go into the methods of how we analyze our data and conclude with the results of our analysis. So we're trying to determine today if the 2010 Supreme Court ruling on the purchase of handguns increased gun-related crimes in the city of Chicago. And we are evaluating gun-related crimes from the year 2006 to the year 2014. And then we use public data from the Chicago data portal, and we ran multitude of tests such as regression, hypothesis, and t-tests.
Okay, the McDonald versus Chicago ruling reinstated the legal use of handguns, and we wanted to know if this ruling had an effect on the handgun-related crimes committed in Chicago. And we hypothesized that the handgun crimes in Chicago increased after this ruling. Okay, so our hypothesis was that there was an increase in handgun-related crime after the 2010 ruling, and our measures were the number of gun-related incidents in Chicago, and we used the years 2006 through 2014 in order to get a big picture of how the gun-related crime was. And then our assumptions were that the 2010 ruling increased access to handguns in Chicago, and then the data set is complete and conclusive, and the majority of the incidents were reported. And we also had to take into account that crimes fluctuate according to the season based on the several circumstances.
So how we gather our data is that we access the City of Chicago's data portal, and they keep the amount of crimes and the descriptions of the crimes for every year. So we started at 2006 and we ended in 2014, and we examined the gun-related crimes, and it had 37,226 rows for evaluation. And then we compressed this in an Excel spreadsheet to show the sum of gun-related offenses. And how we did this is in the Chicago data portal for each month, we entered in the description aggravated handgun and aggravated other firearm, and those are the two variables that we use to determine the amount of gun-related crimes that occurred in Chicago. And the months where guns were legal, we inserted a dummy variable and we put a 1 next to those, and in the months that they were not legal, we put a 0 next to them in the Excel spreadsheet.
So when we initially looked at our data in Excel, we decided it would be a good idea to look at a scatter plot of all the data points that we had. So as you can see, there's very low correlation between the points. So as Kelly said, we decided that we figured that there would be fluctuations in gun crimes by month. So January, February, we decided to look at it that way, as you can see there, due to weather conditions and whatnot. And then after that, we used another method. We decided to look at the regression of the data. But after thinking about it, we decided that we were best served to look at it as a time versus variable standpoint rather than a variable versus variable standpoint, which a regression would more properly do. So lastly, we decided to do a hypothesis test on our data. So we developed an alternative hypothesis that went with our hypothesis, as Kelly said, of the new mean of 2010 to 2014 being greater than the mean of 2006 of 2010. So we ran summary statistics, and using that, comparing it against the alpha value of 0.05 and a level of significance of 95%, we came up with a p-value, which Marcus will now talk about.
First, we ran a linear regression where we used gun violence in Chicago as our dependent variable, and we used month of the year as our independent variable. But we decided not to go with this since we used variable time was one of our variables. Instead, we felt that a hypothesis test would better give a understanding of our data, so it allowed us to run the change in gun crime over time, and we used the p-value as a indicator of the significance, and we noticed that is very high at a value of 0.99.
So in conclusion, we found that the 2010 court ruling did influence gun-related crime, but not how we predicted. So like both Marcus and Peter said, we started off by running a simple regression. We did a scatter plot for all the data points, and we also did line charts for each month. We did the monthly line charts to account for any spikes in data for weather circumstances. And we also found through this regression test that the R-squared value was very low. So there was a slight correlation, and as you can see, it was more downward sloping. So then we chose to do a hypothesis test because we weren't really testing the variables against each other. We were more seeing how the data changed after a point in time. So we found from the hypothesis test that the p-value was 0.999 from the upper tail test, and we chose to do an upper tail test because we predicted that gun-related crimes would increase. And so we got this number for our hypothesis test from the mean in the 5 years prior to the ruling, and yeah. So the downward trend in our scatter plots and line charts were similar to the conclusions that we drew from the hypothesis testing, and ultimately we found that the 2010 ruling to legalize handguns did not increase gun-related crimes. In fact, they decreased it over time.
We can edit.
Press the stop.